Okay, in this problem, what force must be applied at point P to keep the structure shown in equilibrium? Okay, so we are applying a force here. The weight of the structure is negligible. Okay, now for an extended object to be in equilibrium, the two conditions for equilibrium is the sum of all the forces should be zero and the torques of all these forces should add up to zero. All right, now let's say we're applying a force on this object there. That's the force we want to find. Okay, so we'll call this F1, F2. Okay, and again our axis is here's the X and Y axis. Okay, so the first condition, F, sum of the forces should equal zero, is F plus F1 plus F2 should equal zero. Okay, so F, the force we need to apply at that point, is equal to minus F1 minus F2. Okay, and F1 is 4000 I and F2 is minus 2000 J, where I and J are unit vectors. So the force we need to apply is 4000 I plus 2000 J in newtons. That is the force we need to apply to keep the object in equilibrium. And as a check, you can check that the torques of these forces will add up to zero. For instance, if you calculate the torque about this point, this force will make the object rotate clockwise, which would be a negative torque, and this object would make the object rotate counterclockwise. So the torque due to this force is zero, and this force applies a counterclockwise clockwise torque, so which is negative. So minus 4000 newtons times the moment term is 1 meter plus this force applies a counterclockwise torque. This would be positive. So the moment arm about this axis is 2 meters. So yeah, so 2000 Newton times 2 meters, and so indeed that is zero. Okay. Well, anyway, so all the problem asked us to do was solve for this. So that finishes this problem.